Alright, so I think this is recording. Let's take a look at solving these trig equations. Here in number 6 we have a tangent function. We know there's infinitely many solutions to this equation, but they only want us to provide the solutions that are between 0 and 2 pi. When I look at this equation, on the left hand side I have one term, on the right hand side I have two terms. Now the variable of interest, this theta, appears on both sides of the equation. I need to get both of those terms on the same side of the equation. I need to subtract the tangent of theta from both sides of this equation. When we subtract it here on the right hand side, that term is canceled, and when I subtract one tangent theta from the left hand side, then I can treat this as like terms, and if I have 5 tangents and take away one tangent, I'm left with 4 tangents. Alright, so now on the left hand side I have two factors. The factor that contains my variable is this tangent of theta, so I need to divide both sides. The inverse of multiplication is division. I need to divide both sides by 4. So I have the tangent of theta is equal to negative 1/4. To find theta, we take the inverse tangent. Now, if we go and look at a unit circle, we will not find a known value that has a y over x ratio of 1/4 on that unit circle, so I'm going to have to go to my calculator. I do know what to expect. I know that this 1/4, there will be an angle in quadrant 1 that has a y to x ratio that's 1/4, and there will also be an angle in quadrant 3 that will have a y to x ratio of 1/4. In quadrant 3, both y and x will be negative, and the negatives will cancel, but the calculator, when I go to plug this into the calculator, is only going to use the right half of this. It's only going to provide me with this angle that's in quadrant 1. We're going to have to find a way to include this point in our solution, the angle that passes through that point. Alright, so let's go to the calculator. Let's check that we're in radians. And I'm in radians. I'm having the calculator round to the nearest thousandth, which is 3 decimals. And if I go inverse tangent of 1/4, it's going to provide me that angle in quadrant 1. It's given me that this angle in a radian measure is 0.245 radians. Okay. Because tangent has a period of pi, which is different than sine and cosine, secant and cosecant. They have periods of 2 pi. I can get to the next solution by adding integer multiples of pi. So this equation represents infinitely many solutions to my original equation here. Well, all I want is the values of theta that are between 0 and 2 pi. So I can make a little table over here. When n is 0, I have 0.245. When n is 1, let's go to the calculator and add pi. 3.387. When n is 2, let's add another pi. 6.528. Well, 2 pi is smaller than that, right? It'd be 0.28. So that's too big. They don't want this solution. It is a solution to the equation. It's just that it's not between the 0 and 2 pi, so we don't include that. So the only solutions were these two solutions, and we can, if we use the calculator to check it, then we want to basically check the tangent of theta is equal to negative 1/4 because, or plug it in and get this decimal number on the left hand side, plug it in over here, get that decimal number, and see if the two are equal. Well, by the properties of equality, if we've isolated this tangent of theta correctly, then we should be fine. It should check out just fine. You can plug it in the calculator, take the tangent of these two, and see if you get negative 0.25. All right, so let's move on. All right, we have an equation in cosine. Now this time they're wanting us to work in degrees. So I have a variable x that appears in this term and a variable x that appears on that term. That's on separate sides of the equation. I need those to be on the same side of the equation. So I need to add 3 cosine of 3x to both sides. I have one of them over here. When I add 3 cosine 3x's plus that 1, I'll have 4 cosine of 3x. When I divide by 4, so that I can isolate this term that has my variable, 4 divided by 4 is 1, and 2 divided by 4, that reduces. Then I have the square root of 3 over 2. Now it's telling me exact answers, so it wants me to use my unit circle, and I can look at my unit circle and see that there are 2 points that have an x-coordinate of radical 3 over 2. There's one in quadrant 1 and one in quadrant 4. This angle 3x in quadrant 1 will have a measure, I was starting to write pi over 6, but it's in degrees, so 30 degrees. And also in quadrant 4, I believe it's 330, 11 pi over 6. Now, I've got a unit circle on one of these somewhere. Let's go get that and double check that. There we go, to make sure that I'm not making a silly mistake. Alright, so at 30 degrees, the x-coordinate is radical 3 over 2, and at 330 degrees, it's radical 3 over 2, so I haven't made any silly type of mistakes. Now, let's divide both sides by 3, and I have that x is 10 degrees, and over here, x is 110 degrees. Now, it wants all of the solutions that are between 0 and 360. When with this coefficient of 3, that actually was a horizontal shrink, and the period for this is 2 pi divided by that coefficient. So my new period is 2 pi over 3. Well, I need to think of that in terms of degrees. 120 degrees, right? Because 180 divided by 3 is 60. The pi's cancel, and 60 times 2 is 120. So I need to add integer multiples of 120 to these to generate infinitely many solutions that satisfy this equation. They only want the ones that are between 0 and 360. So if we let n be 0, then we've got 10 degrees as a solution. If n is equal to 1, then we have 130 degrees as a solution. If n is equal to 2, that's 240 plus 10, which is 250. And if n is equal to 3, we've got 360 plus 10, 370. That's too big. Over here, let's see what we've got. If n is a negative 1, then that would be a negative 10, and we have to be bigger than 0. If n is 0, we've got 110. If n is 1, then we've got 230, right? And if n is 2, we've got 240, 350, which is just barely under, just under the 360 there. So those are our 6 solutions that satisfy this equation. There were infinitely many, but there was only 6 that were between 0 and 360. All right, so let's do one more, and then I'll call it a video. All right, so again, I have terms on both sides of an equation that contain my variable of interest. I need to get these terms on the same side of the equation and the other terms that don't have the variable on the other side. So when a term changes sides, it changes sign. Now sign S-I-G-N. If I add the sign of x over 6 to both sides of this equation, I get 2 sine of x over 6. And if I subtract 4 from both sides, I have this. Well, now on the left-hand side, I have 2 factors, and the factor that I'm interested in that contains my variable is this sine of x over 6. So I'm going to divide both sides by 2. And I have the sine of x over 6 is equal to -2. But warning signs hopefully are going off. I know that the sine of any angle, whether it's x over 6, any angle, is between -1 and +1. I know that the range of sine, that I'll never have an output that's smaller than -1, or never have an output that's bigger than +1. This -2, it's impossible. This would be saying that the hypotenuse is not the longest side of a right triangle, and we know that it is. We know sine is the opposite leg over the hypotenuse. And it's only when we're on the axis that that ratio is 1. For our right triangles that we can construct, the numerator is always smaller than that denominator if it's the opposite leg over the hypotenuse. The hypotenuse is the longest side of any right triangle. This has no solution. This will never be true. So hey, I hope that helps, and I'll talk to you later.